March 1945, East Bank of the Rhine, Germany. Hedman Klaus Bergman peers through his binoculars. On the opposite bank, American engineers have just started.
12 minutes ago, counts the soldiers.
6 men per panel.
No cranes, no heavy machinery, just steel panels that look identical. His calculations say it's impossible.
Bergman is a civil engineer.
When the Wehrmacht recalled him in 1943, they assigned him to the 12th Engineer Battalion, military engineering, tactical bridges, temporary constructions, strategic demolitions. He learned quickly that war changes everything. You don't design for permanence. You design for function. A bridge needs to last long enough for the army to cross, 3 days, maybe a week.
Then the front moves, and the bridge becomes irrelevant.
But even temporary bridges follow the same physics. Load calculations, material stress, foundation stability. A 60-meter span requires support structures, requires time. Bergman has built 17 bridges in 2 years. Wooden trestle bridges across rivers in Russia. Steel girder bridges over canals in France. Pontoon bridges across the Meuse during the Ardennes offensive. Each bridge took days to construct, sometimes weeks. He has also destroyed 23 enemy bridges, blown railway bridges in Ukraine, demolished highway bridges in Belgium, collapsed stone arch bridges across the Rhine during the German retreat. The strategy was simple. Every destroyed bridge delays the enemy advance by weeks.
Time for German forces to regroup.
Time to establish new defensive lines.
Time to prepare counterattacks.
Operation Plunder began 24 hours ago. The largest amphibious assault since D-Day. British and American forces crossed the Rhine north of Wesel under cover of darkness. 20,000 men established bridgeheads on the east bank.
Another 100,000 wait on the west bank.
They need bridges, heavy bridges, bridges that can carry tanks and artillery and supply trucks. Bergman knows the German calculations. Every Rhine bridge was destroyed during the retreat. Massive stone and steel structures built to carry civilian traffic for decades. The Ludendorff Bridge at Remagen collapsed even after the Americans captured it intact. Too much damage from German demolition attempts. To rebuild those bridges, the Allies need time. Engineering surveys, foundation work, heavy construction equipment, skilled labor. 3 weeks minimum. That's what German intelligence calculated. 3 weeks before the Allies can move heavy armor across the Rhine in significant numbers. 3 weeks for the Wehrmacht to consolidate defenses, to move reserves into position, to prepare the defense of the Ruhr industrial region. The entire German defensive strategy depends on those 3 weeks. Bergman looks through the binoculars again, 30 minutes since the Americans started.
4 modules in position.
He opens his field notebook, sketches what he sees, notes the dimensions, counts the soldiers, records the time. Modular panels, steel construction, approximately 3 mil per panel, 6-man teams, no heavy machinery visible, no foundation work, direct ground placement. He closes the notebook, looks at his watch.
32 minutes on the American bank.
The 5th module slides into position.
Bergman does the math.
If they maintain this pace, they'll complete the bridge in under 6 hours.
Impossible.
But the bridge keeps growing. Bergman observes for another 2 hours. He doesn't move from his position, doesn't eat, doesn't rest, just watches and calculates. The panels are perfectly identical. Every single panel, same dimensions, same weight, same connection points. 3 meter long, 1 and 12 meter high, 260 kg. He counts the holes for the connecting pins. 8 holes per panel, 4 on each end, perfectly aligned. Every panel has the same hole pattern. 6 men lift a panel. They carry it to position. No special equipment, no lifting machinery, just 6 soldiers and a steel panel. They position it next to the previous panel.
The holes align perfectly.
No adjustment needed. No measuring, no checking. 4 steel pins slide through the holes.
1 soldier uses a pneumatic hammer.
30 seconds per pin.
2 minutes total.
The panel is locked in place. Next panel.
Same procedure.
Same timing. Mechanical precision.
Bergman times it carefully.
15 minutes per panel from pickup to final pin insertion. He calculates 60 mile to 3 mile per panel equals 20 panels. 20 panels at 15 minutes each equals 300 minutes.
5. Oh, but that's just the horizontal span.
A bridge needs vertical supports, needs lateral bracing, needs anchoring. He watches more carefully.
The Americans aren't building traditional foundations. No concrete.
No excavation. They're using large steel plates, base plates, heavy but portable. They position them on the ground, check level with a simple tool, and move on.
No waiting for concrete to cure.
No foundation settling time, just steel on earth. The vertical supports are the same panels, identical panels rotated 90 degrees, the same 8 holes, the same 4 pins, the same connection system. Bergman understands now the entire bridge uses one component, one single standardized panel.
Horizontal spans. Use the panel flat. Vertical supports. Rotate the panel. Lateral bracing. Angle the panel. Reinforcement. Stack the panels. Every connection uses the same pins.
Every joint uses the same holes.
Every assembly procedure is identical. There are no special components, no custom pieces, no unique parts for specific locations. A soldier trained to assemble one section can assemble any section. A team that builds the first module can build the 20th module exactly the same way.
Bergman thinks about his bridges.
Every bridge was unique, custom designed for specific site conditions, river depth, soil composition, load requirements. Each bridge required detailed engineering drawings, hundreds of pages, thousands of calculations. Each component was custom fabricated, beams cut to specific lengths, plates drilled with unique hole patterns, connections designed for particular stress points. Building one of his bridges required skilled craftsmen, welders who could read complex drawings, fitters who understood structural engineering, foremen who could interpret technical specifications. The Americans have eliminated all of that. No custom components means no skilled fabrication. No unique designs means no complex drawings. No site-specific engineering means no expert supervision. Just standardized panels and trained soldiers. Bergman watches the assembly teams. 8 teams working simultaneously. 48 men total.
They work with rhythmic efficiency. No confusion. No delays.
No questions.
Every man knows his role.
Panel carriers, pin installers, level checkers, safety inspectors. They've done this before many times.
The movements are automatic. Muscle memory.
Bergman thinks about training. To build one of his bridges, you needed years of engineering education. To assemble a Bailey bridge, you need weeks of repetitive training. Train a soldier to install one panel correctly. Repeat that procedure 1,000 times.
The soldier becomes an expert in that one procedure. Multiply that soldier by 48.
Multiply those teams by hundreds across the entire front.
You don't need a nation of engineers.
You need a system that turns ordinary soldiers into assembly specialists.
Hour 4. The bridge is past halfway.
12 modules complete. Bergman checks his calculations again.
The numbers haven't changed.
3 weeks for a traditional bridge. But this isn't a traditional bridge.
This is something different.
This is industrial warfare.
Hour 6.
The bridge is complete. Bergman times it exactly.
8 hours and 17 minutes from first panel to final pin. The Americans don't celebrate, don't pause, don't rest.
They immediately begin load testing.
A jeep crosses first.
Light vehicle.
Reconnaissance. The bridge doesn't flex.
Then a supply truck.
2 tons loaded. The bridge holds steady.
Then a GMC truck.
6 tons.
Fully loaded with ammunition crates. The bridge absorbs the weight without visible stress. Bergman watches through binoculars. He's looking for specific signs.
Lateral flex.
The slight sideways movement when weight crosses unevenly. Every bridge has some flex. The question is, how much? He sees none.
The bridge remains rigid.
Vertical deflection. The downward sag when heavy loads pass the center point. Physics demands some deflection.
Steel compresses under load.
He measures with his eye. Maybe 2 centimeters.
Negligible for a 60-meter span.
Vibration.
The oscillation that builds when vehicles cross at speed.
Resonance frequency.
Every bridge has a natural vibration pattern. Too much vibration means structural weakness.
The bridge is stable.
No visible oscillation. Then he sees the first Sherman tank. 32 tons of American steel.
Engine, armor, ammunition, crew.
The heaviest vehicle in the Allied arsenal. The Sherman approaches slowly. The driver is cautious.
First crossing, testing the bridge.
Bergman holds his breath. 32 tons on a bridge built in 8 hours. The Sherman rolls onto the first panel.
The bridge holds. No flex.
No deflection beyond normal parameters.
The tank continues.
Center span now.
Maximum stress point.
The bridge absorbs the weight. The Sherman reaches the east bank.
Crosses completely.
Bergman exhales. A second Sherman approaches, then a third.
The Americans aren't testing anymore.
They're using the bridge operationally.
Bergman recalculates.
Each panel is rated for how much load. He estimates based on what he sees. The steel thickness, the truss design, the connection strength, 20 tons per panel minimum. But the Americans built double layer sections at key stress points. Overlapping panels connected vertically with the same pin system. Double panels mean double capacity, 40 tons, sufficient for any vehicle the Allies possess. Bergman observes for another hour. He counts vehicles, jeeps, trucks, half-tracks, tank destroyers, artillery tractors, supply vehicles, ambulances, command cars. The bridge handles everything. No delays, no weight restrictions, no special procedures. It's not a temporary bridge.
It's a highway.
Then he notices something 3 km downstream. Another American engineering team, another bridge, same design, same panels, same assembly procedure. Bergman shifts his binoculars, counts the modules. They started after the first bridge, maybe 2 hours behind, but they're catching up.
Same system, same training, same result.
He understands now.
The Americans aren't building a bridge.
They're building a network, multiple crossing points, simultaneous construction, redundant capacity. If the Germans destroy one bridge, 3 others remain operational. If one bridge reaches capacity, traffic diverts to another. If one crossing point comes under artillery fire, the entire operation doesn't stop. It's not engineering, it's logistics. Bergman opens his notebook, calculates. If each team builds a bridge in 8 hours, and the Americans have 10 teams along this sector of the Rhine, they can build 10 bridges in 1 day. 10 bridges in 1 day. The Wehrmacht spent 6 months destroying 23 bridges across the Rhine. Months of preparation, tons of explosives, careful demolition to ensure complete destruction.
The Americans can replace them all in 3 days.
Bergman stares at that calculation, checks it again.
The math is correct.
3 days to rebuild what took 6 months to destroy. He thinks about German defensive planning.
Every destroyed bridge was a victory.
Every collapsed span meant weeks of delay for the Allied advance.
Time for the Wehrmacht to regroup. Time to establish new defensive lines. Time to move reserves into position.
The entire strategy depended on those destroyed bridges, on the time required to rebuild them.
3 weeks.
That's what German intelligence calculated. 3 weeks minimum for the Allies to restore Rhine crossing capacity. Bergman looks at the American bridges.
2 complete.
A third under construction.
All within visual range.
Not 3 weeks, 3 days.
The defensive strategy is obsolete.
Bergman returns to command headquarters at 2200 hours.
The colonel is waiting in the operations room. Maps cover the walls.
Red marks indicate destroyed bridges. Blue marks show German defensive positions.
Report helped.
The Americans completed 2 60mm bridges today.
8 hours per bridge.
Load capacity 40 tons.
Modular prefabricated system. The colonel notes this on his map.
Can we destroy them? Yes, Herr Ost. But they will rebuild them in 8 hours. Silence.
The colonel stops writing.
8 hours.
Harrow burst.
I observed the complete construction process.
Standardized panels.
Trained assembly teams. No specialized engineering required. The colonel looks at the map. 23 red X marks. 23 destroyed bridges. The defensive plan is built around those X marks. 3 weeks without bridges. 3 weeks to prepare defenses.
3 weeks to move the 15th Army into position.
How many teams do the Americans have? Bergman thinks about what he observed.
I counted 2 teams in my sector.
Intelligence reports similar activity along the entire Rhine front from Emmerich to Karlsruhe. How many bridges can they build? Bergman calculates. If they have 10 teams per sector and 3 sectors, 30 bridges per day, they can replace every destroyed Rhine bridge in 1 day. The colonel sits down heavily, looks at his defensive plans, troop movement scheduled over 3 weeks, artillery positioning, supply line establishment, reinforcement schedules, everything calculated for 3 weeks of preparation time. The defensive plan is obsolete.
Yes, Herr Ober.
The colonel stares at the map, doesn't speak for a full minute. Bergman thinks about the Bailey Bridge. It's not just a bridge.
It's a system.
A complete system that transforms bridge construction from engineering art into industrial process. The Americans didn't invent a better bridge. They invented a better way to build bridges. And Germany cannot copy it. Not because the design is secret, not because the engineering is too complex, because Germany lacks the industrial capacity. The Bailey Bridge requires mass production of identical components. Thousands of panels, tens of thousands of pins, hundreds of base plates, all manufactured to exact specifications, all interchangeable. Germany's factories are destroyed. The Ruhr is under constant bombardment. Steel production has collapsed. What factories remain are producing tanks, aircraft, ammunition. There is no capacity for a new bridge system. The Bailey Bridge requires standardized training for thousands of soldiers. Repetitive drilling until assembly becomes automatic. Training facilities, training time, training personnel. Germany's training system is collapsing. Recruits get 6 weeks of basic training and go straight to the front. There is no time for specialized engineering training. The Bailey Bridge requires a logistical system to distribute tons of steel across hundreds of kilometers. Railways, trucks, depots, coordination. Germany's railways are bombed. Bombed daily. Trucks lack fuel. Supply lines are chaos. The gap isn't technical. It's industrial. Bergman thinks about his Würzburg Bridge. 3 years of design, 2 years of construction. A unique work of engineering art calculated for that specific location, that specific river, those specific conditions. Beautiful, elegant, permanent, useless in modern war. The Americans build bridges like they build tanks, like they build aircraft, like they build everything. Mass production, standardization, interchangeable parts, industrial efficiency, not art, industry, and industry wins wars. Bergman writes his final report at 200A. The headquarters is quiet. Most officers are asleep. He sits alone with a single lamp and his notebook. The Bailey Bridge represents a paradigm shift in military engineering. The system eliminates the need for specialized engineering at the deployment site. Any trained team can assemble a bridge in 8 hours using standardized components. He pauses, considers his words carefully. This report will go up the chain of command. We'll reach officers who make strategic decisions. Strategic implications. Germany's defensive strategy based on destroyed bridges is obsolete. The enemy can restore Rhine crossing capacity faster than we can destroy it. Current defensive timelines based on 3-week bridge reconstruction are invalid. Actual reconstruction time 8 hours per bridge. He writes the final paragraph. Tactical recommendation. Redirect defensive resources from bridge destruction to bridge approach defense. Focus artillery on crossing points, not bridge structures. The enemy will rebuild any bridge we destroy within 1 day. Our advantage lies in defending the approaches, not destroying the spans. He signs the report, knows it will go to division command, then to corps, then to army group. Each level will add comments.
Each commander will adjust the assessment to fit their own understanding.
By the time it reaches someone who can actually change strategy, it will be too late. Bergman thinks about the engineers who designed the Bailey Bridge. Donald Bailey, British engineer. He probably never saw combat, never built a bridge under fire, never watched soldiers die because a bridge took too long to construct. But he understood something fundamental about modern war. Speed matters more than elegance. Standardization matters more than customization. Mass production matters more than perfection.
The Bailey Bridge isn't the best bridge ever designed.
It's the best bridge for industrial warfare. And that makes all the difference. The Bailey Bridge became the most widely used military bridge system in history. Over 200 different configurations, deployed in every theater of World War II, from the Rhine to the Burma Road, from North Africa to the Pacific Islands. By war's end, Allied forces had built over 3,000 Bailey bridges. Total length, over 1,000 kilos of bridging. Some still stand today, converted to civilian use in Europe, Asia, and Africa. The system Bergman observed that March Day in 1945 represented more than engineering innovation. It represented the industrial advantage that decided the war. Not courage, not tactics, not strategy, production capacity, the ability to turn raw materials into functional systems faster than the enemy could destroy them. That's how wars are. If you enjoyed this video and want to see more stories from World War II, make sure to subscribe to the channel. Your support helps us bring more forgotten battles, hidden histories, and untold soldier stories to life. And let me know your thoughts in the comments. What event or perspective would you like to see next? I read every comment.